A 2 kilogram block is attached to an ideal spring for which K equals 200 and initially at rest on a horizontal frictionless surface as shown in the diagram above. In an initial experiment, a 300-gram or 0.3 kilogram ball of clay is thrown at a 1 kilogram block. The clay is moving horizontally with speed v when it hits and sticks to the block. The spring is attached to a wall as shown. As a result, the spring compresses a maximum distance of 0.5 meters.
Oh, can you guys interpret this diagram again?
The ball hits the box and
The ball has what velocity?
V.
V0.
It's V initial.
Okay, this is the initial velocity, right? And this one is the box which is
Yes.
attached to.
The spring.
Is it being compressed?
And not compressed until the clay hits the block.
Until the clay hits the block.
So this is before,
Yes.
so it has K, right? So
Yes.
after, what happened after?
After the clay sticks to the box and the spring is compressed
By how much?
by 0.5 meters.
So I'm just gonna put a distance X.
Yes.
And that's when the clay and the box embedded together, right?
Mm-hmm.
So this is before and after. So I'm just gonna go ahead and write out the initial. This is what?
Fine.
Final, okay. Just give me the values again about what we have. What's the mass of the M1?
According to the
M2?
question,
What's the, no.
Oh.
M1, what's the mass of M1?
the mass of M1 is 0.3 kilograms.
Okay. Okay, what's the mass of M2?
Let's see.
Remember, it's supposed to be larger.
Yeah, 4 kilograms.
Okay, what's the K constant?
400.
Oh, Newton meter. And then what else do we know?
We know the X. The
Oh.
delta X.
Which is
0.8.
8 meter. So these are the given information. I want you to go ahead and solve it
Mm-hmm.
once we finish deriving the equation. So we're gonna go ahead and look at the initial and the final one to see what we have. So at the initial one right here, what do you have? Equal final?
Yes.
What types of energy do you have at the initial velocity?
In the initial, you have kinetic energy.
And kinetic energy, right?
Yes.
Okay, look at what the question is looking for again.
It says looking for the energy stored in the spring at maximum compression.
Okay, so that energy right now, so I'm not gonna go, so I'm gonna put it on the side right here. So that energy right here is potential energy, which is equal to 1/2 kx squared.
Yes.
And you substitute your values, what do you have? So that would be 1/2, what's my k?
Your K is 400 meters.
400. What's my compression distance?
0.8.
0.8 squared. Okay, go ahead and give me the answer right here.
$128.
Did you get the same answer?
Yes.
Yes.
128?
Mm-hmm. Joules.
Okay. So now we're going to use the momentum. So is it elastic or inelastic and why?
It's inelastic because the clay sticks to the box.
Stick together, right? That's the key word. So you're going to have to write that down first. I'm just going to say PI. What's PI stand for again?
Momentum. Initial.
Okay. How many different objects do you have?
2.
And that's why I add them up.
Yes.
At the end of the collision, what happened to the masses?
They combine.
Then you're going to have to like combine the masses, right?
Yes, and they have
And then
one
you're looking-
velocity.
You're looking for final velocity.
You're looking for the energy. For the second one, the speed of the clay ball immediately after the clay sticks
So
to
which
the ball.
variable? Is it this one or that one? Or
It's
that
VF.
One? It's VF, right? So that's what we're looking for. So I'm gonna go ahead and circle them because you're gonna have to isolate this, right?
Yes.
So now, based on your question, can you interpret what's
Yes.
given? Do you have mass one?
Yes.
Yes.